All right, we're going to be looking at inverse functions today. An inverse relation is a relation that switches the input and output values of an original relation. If a relation and its inverse are functions, then the two functions are what we call one-to-one functions. So for functions f and g, in order for them to be inverses, the composition of f of g of x must equal to x, and the composition of g of f of x must also equal to x. This is one of those instances where the compositions, when you switch them, come up with the same answer. In this case, we want them to both be x values. The inverse of f is denoted by f to the negative 1, which reads as f inverse. So we don't say f to the negative 1. We just reread it as f inverse. So first thing we're going to do is we're going to verify that these two functions are inverse functions. So we're going to show that the composition of f of g of x is equal to x, and the composition of g of f of x equals to x. So first thing we're going to do is we're going to look at f of g of x. So if you're still struggling with compositions, it's a nice little practice as well. Remember, we're going to plug g of x, this inside function, into our f function. Okay, so we have our f function. We're going to plug in our g of x, which in this case is 1/2 x minus 3/2. So our g function, 1/2 x minus 3/2, we're going to plug in to the x value of our f function. So this looks like 2 times, remember to use parentheses. Parentheses are very important when you're plugging in or replacing or substituting. So we're going to plug in negative 1/2 x minus 3/2 where that x is, and then we have plus 3. So next we're going to distribute. So 2 times negative 1/2 x. I'm sorry, that should not be a negative. Sorry. 2 times 1/2 x is 1x. 2 times negative 3/2 is a negative 3. And then we have this plus 3 at the end. When we combine our like terms here, we're left with just x. So f of g of x equal to x. That works out. If it did not equal to x, you do not need to keep going. Because in order for them to be inverses, they both have to equal to x. So if the first one does not equal to x, we don't have to waste our time checking the second one. But because this one does equal to x, we now need to see if g of f of x also equals to x. So we're now going to plug in our f of x into our g of x. So we're going to plug f of x into the g function. So this is g of my f of x is 2x plus 3. So what we're going to do now is, in my g function, right here where the x is, we're going to replace that with 2x plus 3 using parentheses. And then we have minus 3/2. So we're going to distribute 1/2 times 2x is 1x. 1/2 times 3 is 3/2. And then we have minus 3/2. When we combine like terms here, we're left with just x. If you still get confused with fractions, please use a calculator. Now, as you can see here, both of these equal to x. Perfect, that's what we wanted. Now we can say, because f of g of x and g of f of x both equal to x, then f of x and g of x are inverse functions. So now what do inverses look like graphically when we're looking at a graph? Well, remember, since inverse functions essentially just switch the x and the y, the inverse function is just a reflection over the y equals x line. So we can see here, to go from here to here, we're just switching the x and the y values. -2, -1 became -1, -2. -1, 1 becomes 1, -1. So let's look at some functions. So with number 1 here, we have discrete data, so we're just going to plot some points. We're just going to, not plot some points, but identify some points. And I'm going to use a table. You can do ordered pairs if you want to. I just like the way the table looks. So we have this point here is -4, 3. This point here is -2, -4. This point here is 1, 1. This one is 3, -5. And this one is 4, 2. Now, it doesn't matter what order you put these points in. To get the inverses, we're just going to be switching the x and the y. So to get my inverse of this function, just going to switch the x's and y's. So this becomes 3, -4, -4, -2, 1, 1, -5, 3, and 2, 4. So when I plot those points, we have 3, -4, -4, -2, 1, 1, -5, 3, and 2, 4. And it talks about being reflecting across that y equals x. So this point and this point are reflections. This point and this point are reflections. This point and this point are reflections. This one's on that y equals x line, so that is a reflection of itself. And those two are reflections. You can do the same thing with continuous data. So just like before, I'm just going to plot, pick some points on this quadratic. So on this function, I'm just going to pick some points. I'm going to pick -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So for its inverse, again, we're just going to switch the x's and y's. So this becomes 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. So when I plot those, I get this quadratic right here. So that is your inverse function graph. It's actually not your inverse is actually not a function. It fails that vertical line test. So the function, right, the first graph is a function, but the inverse is not a function. Next, we're going to look at how do we find the inverse? So they gave you a function. How do we find the inverse of that function? So we're going to follow these 4 steps. So step number 1, we're going to replace that f of x with a y. Everything else stays the same. Step 2, we're going to switch the x and the y. So this becomes x equals 4y minus 1. Step 3, solve for y. This could be 1 step, 2 steps, 3 steps, just depends on what your equation looks like. So I'm going to add the 1 to the other side and then divide everything by 4. This leaves me with 1/4 x plus 1/4 equals y. And again, that's a 1/4 x because there's a 1 in front of that x that we don't write down. So it's just 1/4 x plus 1/4. And step 4, we're going to rewrite this in function notation, inverse function notation. So f inverse of x is equal to, and then we're going to write the function 1/4 x plus 1/4. So I'll do a couple examples, and we're just going to follow those steps. So with number 1, we're going to rewrite this as y equals 2/3 x plus 4. That's step number 1. Step 2, we're going to switch the x and the y. Oops. Step 3, we're going to solve for y. So I'm going to subtract that 4 to the other side. And if you remember from Algebra 1, to get rid of a fraction, we multiply by its reciprocal. To get rid of that fraction. So we multiply both sides by that 3/2. Be really careful. It's not just the x that we're multiplying, it's the x minus 4. So when we distribute, we get 3x, 3/2 x. 3/2 times -4 is -12/2, which is just -6. These canceled out, we're left with just y. And the last step is to rewrite this as f inverse. So this is f inverse of x of 3/2 x minus 6. And that is the inverse function.